Have you ever thought about how people are often uncertain about things in their daily lives? That's where probability distributions come in. And these distributions are the foundation for everything we do in Bayesian statistics. In this video, we will talk to you about a Python library that efficiently works with these distributions. That is PyMC. And we'll take a look at some of its key features.
Now, let's talk about the key feature of distributions in PyMC. PyMC provides a comprehensive library of probability distributions, which are essential for defining prior belief, likelihood functions, and posterior distributions. And these are the definitions of them. PyMC supports both continuous and discrete distribution. These are some examples of such distribution, and this code here shows the normal distribution. Additionally, PyMC allows you to create custom distributions using pm.density dist when built-in options don't fit your problem. For example, this code defines the custom log probability distribution where values closer to zero are more likely. Finally, PyMC makes it easy to generate random samples from this distribution, whether it's prior sampling or posterior sampling using MCMC algorithm. For example, this code generates and visualizes 1,000 samples from a normal distribution.
So here in this part of the video, we are using PyMC to generate a binomial distribution using the function PyMC.binomial. Here is the PNF, that is n chooses x, p raised to power x, 1 minus p raised to power n minus x, whereas n is the number of trials, p is the probability of success, and x is the variable that goes from 0 to n. So here is the code I have written to generate two binomial distributions. Here are three libraries which I have imported. N1 and P. I have generated two binomial distribution in this. So N1 and P1 are the number of trial and probability of success, and respectively N2 and P2. With PM.model generates a probability space inside which we have taken two random variables, binom 1 and binom 2, where I have given the number of trial and probability of success from there here, and use PM.binomial to convert into a binomial random variable. Trace what this line does is that it samples the binomial distribution 10,000 times. I have given it 10,000 times and converts it into the number of success each time it occurs. Now, what samples 1 equal to trace.py binom 1, these lines does it that it generates an array of length 10,000 which contains the number of success each time is happening, which will be from 0 to n only, because x can go only from 0 to n. And what these lines x1 and x2 is that it will take the unique values from sample 1, which will obviously be x, which will be from 0 to n, and return the count of that, how many times that particular success has occurred. Now y1 and y2 are the PMF respectively, which are you generated using relative frequency probability, the count of the particular success divided by the total sampling time. So the total sample space will be 10,000 here, and the count of that particular will be generated by the sample here and taken here. So these are the PMF, and we have used matplotlib to plot the distribution. So the distributions looks like this. This is the second distribution, the yellow one, and this is the first distribution, the blue one. In y-axis we have the PMF of x, and in x-axis we have the variable x, which goes from 0 to n.
To sum it up, PyMC makes working with probability distributions simple and powerful, especially for Bayesian inference. It helps model uncertainty, update beliefs with data, and is widely used in fields such as finance, healthcare, and machine learning. And to work with data and uncertainty, PyMC is a great tool to explore because it makes our lives easier. So that's it for the video. Thanks for watching.